This is just a brief video showing the relative potential switch setup. Series stack, 3-volt relative potential, parallel stack are those three, 6 batteries total, all D cells. Oscillator runs at about 89 kilohertz on this coil, which is 526 lits, 2 wires for power, 2 wires for recovery, 1 wire for trigger, wired with the circuit shown in the schematic, 1 transistor, the resistances. This is the switch 2 that switches out this series string of resistance and switches it back in. Right now it's switched in because that switch is open. This is the on and off switch S1. So I'll shut this off. We have to turn S2 shorted. Note the light goes out. Amp draw is at about 400. So we'll shut this off. This thing's been running on these same 6 batteries for about a month now, with different configurations on the output, and swapping the batteries about 4 times total, so about once per week. So what we do is you flip S1 on first. With S1 on, you get the high draw. You get no LED output until you switch the series resistance back in. Once you switch the series resistance back in, the input goes from the 400 milliamp down to 50 milliamp. Sorry, that's even less than 50 milliamp, but I would need a better resolution ammeter, which I don't have, to show the exact figure there. What's curious is that this is a passive SCR discharger set up with a 2.4 volt Zener in series to be the trigger voltage for the gate, which is then discharged into the light. But if I disconnect the lead to the light, you can see that the input current goes up to about 50 milliamp, while connecting it back up, it drops. Interesting, huh? Another thing to note is that this is the capacity that's being fed out with a single half-wave bridge from the collection strand of the oscillator. And you can see the LED, and if I short this coil back over, if I can bend over, let's see, so alright, so I short that, you see the LED dims. It dims because I add capacity. Without the capacity, that pulse comes out and goes directly through the LED. The LED is a 3 volt 30 milliamp LED, and the relative usefulness of this extra circuit is debatable, because you can also just connect it directly to the LED like that, and when you do that, you actually see an even bigger drop than you do when you have the passive SCR thing in the circuit. So that's just one diode, though, or one LED that's being lit. But look at the draw, it's next to nothing. And anything that's coming out of these series batteries is going through the oscillator and charging these 3 batteries. So you at very least have a 1-to-1 unity faction because of the output input. Then these can always be pulled out and made to be input, and these would be replaced over here to be output, and back and forth. If you add a solar cell or another earth battery, or some other voltage source that can charge a capacity, which can be intermittently discharged back into this stack or that stack, it's better to probably charge the parallel stack, since that's what's taking the charge. And use another option with this is to be able to run the output from this collector strand through one side of the diode, and then out to the negative bus here from the negative side, and then run the positive side over to this end of the series stack. Doing that actually causes this battery, the parallel battery stack, to go up a bit and charge a little quicker than it would otherwise, versus if I disconnect the LED from this side and connect it to this side on the parallel stack, In that case, the battery's voltage on the parallel stack actually drops, which is odd. So it doesn't charge as fast as if this is being shorted back out through the series stack, which is an interesting thing to maybe dig into further as well. So one of the next things I'm also going to do is to swap out this coil with that coil. This is 3 1-pound strands of 18 gauge magnet wire wound on a common form. Like I said, that's 526 lits wound on a much smaller form, and it has a higher resistance. And I'll have to get the characteristics for the coil exactly. You can see what's on here. This is 8.11 millihenries and 2.5 ohms per strand. So that'll be a much lower resistance, so probably get a higher pulse rate, and it might get higher throughput in terms of the current that's drawn. We'll have to see how that looks, compare the two coils. Anyway, that's the relative potential switch for now. Bigger batteries, bigger volts.